Hello students, this is Shalini and today we are going to discuss the very important part of class 12th maths, that is differentiation. So differentiation has two methods to solve. One is the direct method and other is the first principle method. So today we only discuss the first principle method. Students generally found difficulty in solving the derivative by first principle method. So first we just go to the detail of differentiation. What is differentiation and how we are going to solve the differentiation by first principle method. So our topic is differentiation. Differentiation is finding the derivative of a function with respect to an independent variable, and it is represented by d by dx. X is the operator here on which we are doing the differentiation, with respect to which we are doing the differentiation. So differentiation has two methods. One is the direct method, where we need to just only use the formula, like sin x becomes cos x, x square derivative is 2x. So in one line you can easily get the solution, and in the other, this is first principle method. First principle method is only one formula, and that is, it is represented by f dash x equals to limit h tends to 0 f of x plus h minus fx over h. So this formula we are going to discuss, we are going to use in our questions. So now we are going to discuss some of the basic questions, then we'll move on to the higher level questions also. But first we go to the basics of first principle method. What is first principle method? So this is the formula we are going to use in the first principle method. Now we solve this. I'm writing the formula over here in the starting so that we will not find any kind of difficulty in solving the problem. Limit f dash x equals to limit h tends to 0 f of x plus h upon h. So first question we are going to discuss is find the, in question it is, in exam it is mentioned that by which method you need to do. If it is written first principle method, you don't do it directly. So find the derivative of x cube minus 27 by first principle method. Now what we are going to do in the starting is, first we need to let the function, let y equals to, or you can take it as fx, it will be easier. Fx is equals to x cube minus 27, where x is an independent variable. X is the operator on which we are doing the differentiation. So now we write differentiate both side with respect to x. So it becomes f dash x. F dash x means what? D of f upon d of x. So I'm writing this also here, d of f of x upon dx. Now limit h tends to 0 f of x plus h minus fx upon h. This is the formula. Now we need to do the differentiation. So f dash x equals to, now what we need to do is we need to replace x by x plus h. We need three things to solve the values. We need three things, right? One is f of x plus h, other is fx, and third thing is h. So what is f of x plus h? So first we'll solve f of x plus h. And as we know that f of x here is I'm just writing it with a different color so that you can, understand the things very well. So that is f of x equals to x cube minus 27. This is as it is, we can put in the over here. Then f of x plus h is, so we need to replace the x by x plus h now. So what we are going to do is x plus h whole cube minus 27, and a plus b whole cube is, we have a cube plus b cube plus 3ab into a plus b. So x cube plus h cube plus 3ab into a plus b. And we further solve it to x cube plus h cube plus 3x square h plus 3xh square. Now, in the next step, we will do, what we are going to do is, now we will put the values. So f dash x equals to limit h tends to 0. F of x plus h is x cube plus h cube plus 3x square h plus 3xh square minus fx. Fx is x cube plus 27. So we'll change the sign over here. In the next step, we'll change the sign over here because it's negative sign outside, and upon h. Now limit h tends to 0. X cube cancels each other. And there is one more 27. You can write it over here. So we'll have one more 27. Just wait. Yeah. There is one more 27. Just I'm correcting over here. Yeah. Now minus 27, because this is 27. So this was here. Minus x cube minus 27. So x cube, I told you that it cancels, and 27 now also gets cancelled to this 27. Now what is the left part is h cube plus 3x square h plus 3xh square over h. Now, in the denominator, we cannot have 0 because h tends to 0. So in finally, we need to put it as 0. If we put h as 0, the value becomes not defined. So what we're going to do now is we take the common so that this h must be cancels. So we take h as common. Left part is h square 3x square plus 3xh over h. Now h can be cancelled. Now, in the denominator, we have not any kind of h. So will not, leads to not defined part. Limit h tends to 0. H square plus 3x square plus 3xh. Now we'll put the value of h as 0. Because we are already got the simplified form plus 3x into 0. So we get, first part is 0, third part is also 0. So the left part is 3x square. So this is the solution by first principle method you will get. Now we'll move on to one more question, and that is the one we take it as in trigonometric functions we solve. So the second question is, find the derivative of sin x by first principle method. So again, we will, as we have done in the previous question, like that in the same way we will do in this question. Let fx equals to sin x. So first we need to consider the function as sin x, then differentiate both sides with respect to x and you can write with limits h tends to 0. So f dash x becomes limit h tends to 0, f of x plus h minus fx over h. So again, we need three things: h, f of x, and f of x plus h. So I'm again changing the color. Yeah. So fx becomes sin x as it is given, and f of x plus h is, now again we need to replace x by x plus h. Earlier also we did this, now also we do this. So sin x plus h, and then h is as it is, so h has no any kind of value, so h is as it is we put. So now we put the values. F of x plus h is sine of x plus h minus sine of x over h. Now we use the formula of sine of x plus h. So what is the formula for sine of x plus h? Is sine a plus b. We'll use this formula. So we always write the formula when we are using it: sine a cos b plus cos a sine b. So now f dash x becomes limit h tends to 0, sine x cos h, because a is x, b is h, cos x sine h minus sine x, now over h. Now we just put the values, or we can do, yeah, we just put the values. Sine x cos 0, h, 0 have value. Yeah, cos, see, first we have to just simplify a little bit. So sin x cos h plus cos x sin h minus sin x. So we just divide the, the LCM division we will do like this. And separately we just, put this limits, limit h tends to 0, limit h tends to 0. Now, in the next step, what we are going to do is, yeah. So now this part leads to our 0 part. If we put cos h, h is 0, then sin x and sin x will cancel each other. And the left part is limit h tends to 0, cos of x, and cos 0 is 1. That's why I told that sin x cancel each other, because this complete whole is 1. Cos x, so left part is the middle part, this one. Now cos x limit h tends to 0, sin h upon h, and this value leads to 1. So now we get it as cos x. So this is the solution which we solved by the first principle method. I hope you understood the first principle method, and if there is any question you can ask, and thank you so much.